In this video, I want to talk about how to solve a rational inequality. So, a rational inequality is when we have a rational function that's part of an inequality. So, the first step is we want to figure out, so it's asking us, where is this thing less than 0? So, well, I'm not sure, but I know that it has something to do with this function, and the function is f of x is equal to x minus 4 over x squared plus 7x plus 10. And if I want to know what this function looks like, the first thing I want to do is factor the bottom. So I have x minus 4 on the top, and then x, let's see, I'm looking for two numbers that multiply to be 10 and add to be 7, so plus 5 and plus 2. Okay, so when you think about a rational function, it sometimes switches over from positive to negative when it crosses through 0, right? So like, let's just draw, this is just a really quick sketch of a rational function. Let's see. It might cross through, right? So here would be a 0, and that would switch from negative to positive, but it also sometimes switches when it crosses over the asymptote. So like from here to here, it might switch from negative to positive across an asymptote. And then same thing here, it might switch from negative to positive across, or from positive to negative across this asymptote. So we're looking for all the zeros and all the vertical asymptotes. So it might switch from positive to negative. So it might change signs at a vertical asymptote. At a vertical asymptote. Or it might change signs at a 0. So it might change signs at a vertical asymptote, and it might change signs at a 0. So, knowing that, let's see. Let's look at all the places where this function has either a vertical asymptote or a 0, and I'm just going to put them on a number line. So this has a 0 at x equals 4, and it has vertical asymptotes at -2 and -5. So the best way, I think, with a rational inequality is just to go ahead and test some points. We don't need to see exactly what the points equal, but we just need to see if they're positive or negative. So if we have put in, for example, -6, it's going to be negative on top, and then a negative times a negative on the bottom. So negative over positive is negative. So it's going to be negative over here. And you can find out what the actual value is. It's just that we don't really need to know. We just need to know if it's positive or negative. So here, let's try to test -4. So -4 is going to be negative on top, positive here, and negative here. So a negative over a negative is positive. Let's test 0. So we're going to have negative on top, positive, positive on the bottom, so that's going to be negative. And then let's test like 5. So positive on top, positive, positive on the bottom, so this is going to be positive. Okay, it's not always going to alternate like this, but it's pretty typical. If you have a double root or something like that, that's when you'll have, if you have a double factor, that's when you'll have like a plus plus or a minus minus, 2 in a row. But typically with kind of a standard function, you'll have a plus minus, but it's good to just check them all just in case. Because it's easier than trying to figure out, it's easier than trying to figure out what all the graph is totally going to look like. I think it's easier to just test the points in this case. So here's our points. And so it's asking where is it less than 0. So it is less than 0 anywhere where it's negative. So from here, and then also here, less than 0, here to here. Okay, so it would be from negative infinity to negative 5, and then from negative 2 to 4. Okay, now I actually want to change the problem just a little tiny bit and see what changes. So let me get rid of our answer. Now, what if this had said less than or equal to? So I know the temptation is to just say, okay, well then we just fill in all these circles and then we're good. Well, the thing is that zeros are different from asymptotes in this case. So if we're asking where is it less than or equal to 0, well, at a vertical asymptote, is it equal to 0? No, right? At a vertical asymptote, it's like going off to infinity and it doesn't exist. It's dividing by 0, but it's not equal to 0. So if it's a less than or equal to 0, we cannot fill in this circle because this is a vertical asymptote. So this is a vertical asymptote, and this is a vertical asymptote. So we cannot fill in either of these circles. They do not equal 0. But x equals 4 does equal 0. So we can fill in that circle. So if it was less than or equal to 0, the answer would be from negative infinity to negative 5, union negative 2 to 4. And 4 would be the only one with the closed bracket because that's the only one that actually equals 0. The other ones are asymptotes, so they are something divided by 0, which breaks the function, doesn't work. It's definitely not equal to 0. And that's how you solve a rational inequality.